of us. Welcome to part 3 of our theory workbook going through for electromagnetic induction. So let's look at question 2. Question 2 is a cathode ray oscilloscope. What change in voltage results in the position of the spot of the screen moving towards the top? So if the screen moves towards the top, it's most likely this panel that is doing it. So what's happened when it moves to the top itself? Because there's a positive charge here, the other side is 0 volts because it's grounded. For it to actually go towards the top plate itself means that there has to be a positive charge being applied at the top. So if a positive is being applied on the top itself, is due to an increasing V2. That's why the results in the spot moving towards the top. Okay. If it moves left or right, then it's due to because of V1. But because it now moves left or right, it moves towards the top, is due to increasing of V2. Okay. So that is for part C. Number 3, a diagram shows a trace on oscilloscope set at 5 volts per centimeter cube on the vertical axis. 5 volts per centimeter. So if this is 5, this will give us a likely of about, let's count the number of boxes. So 1, 2, 3, 4, 5. 5 boxes is for 1 cm. 1, 2, 3, 4, 5, 6, 7, 7.5. So it's about 7.5 boxes. So it's about 1.5 cm. So if 1.5 cm is out, it means it's 1.5 of 5 volts. So that means it's 1.5 of 5 volts. That will be around 7.5. So that is basically, we are just basically measuring the divisions, and then we find based on 5 volts per centimeter cube. Okay, so the answer is C. Let's look at section B, question 5. So shows up oscilloscope trace of an alternating input voltage. The time base is set at 50 milliseconds per division. Determine the period of the input signal. So we want to find the period. So we know that one period is basically from here to here. So we know there's 2 divisions. If this is per division, 2 divisions of 50 ms times 2. Or you can calculate the full thing, and then you divide it by the number of waves, which is 5, which is what they have done here. So the period is 100 milliseconds. Calculate the frequency. Frequency is basically T equals to 1 over F, or F is equal to 1 over T. So if we know that the period is 100 milliseconds, is equals to 0.1 seconds, using the formula you can find that it's actually 10 hertz. So the time base is set to 10 milliseconds per division. That means each division here, the horizontal axis is 10 milliseconds. Draw the new waveform display on the screen. So now your time base have changed. Originally, your time base is 50 milliseconds per division, so you can have more waves. But now, each division is only 10 milliseconds. So what is your time? The wave itself requires 100 milliseconds. So you have how many boxes here? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 boxes. Just nice, you should be able to just fit one wave, because this is the period for one wave. Because one wave, the period is 100 milliseconds. So you can just nice fit one wave. Okay. Next, question 6. Question 6 is a cathode ray oscilloscope with the time base switch off and the gain set at 5 volts per division. So time base switch off means that it will not oscillate left and right, you only go up and down. So it doesn't move towards the left or right. So describe what you see on the screen when Y is connected to a negative terminal, or this could be grounded. And here is towards a positive with a value. In this case, will be equal to 15 volts battery. So what will happen is the electron beam, since there is a 15 volts battery and the electron is moving through the CRO, when the electron is moving through the CRO, in this case, it will be deflected towards a positive, because electron is negative, the interval is positive, they will get attracted, so it will move towards a positive plate, and in this case, it will be deflected downwards, causing a spot to be observed at the screen. Okay, so now this is a spot. It doesn't move up and down, it's just deflected consistently, giving just one spot. How about for the distance itself? Down here, say that the distance of 3 interval. Why? Because there's a 15 volt applied. In this case, the interval is set at 5 volts per division. So if it's 15 volts, how many divisions do you need? Yes, 3 divisions below 0. So it's downwards, but with 3 divisions below. Okay. Next point, AC supply of 50 Hz and 40 volts is connected across Y. So now there is 40 volts. If there is 40 volts itself, it means that the division, there will be 8 divisions. Okay, 8 divisions up or 8 divisions down. Since it's an AC supply, it means that the positive, the terminal will be changing top and bottom. So which means that there will be a vertical line spanning 16 divisions from peak to peak. So 8 above positive, 8 negative. So a time-based switch is switched on with a period of 0.04 seconds. Sketch the corresponding waveforms for AI and A to indicate the number of division. So now your time base is switched on. That means you'll move left to right already. When you move left to right, the period will be of 0.04 seconds. So what will happen? For the first one itself, there is a spot. Since there is a spot and the time base is on, meaning it will move left to right, what will happen is one spot will become one line below and it will be 3 divisions below. So you got to draw this out, a straight line and 3 divisions below. The next one is because it's 8 divisions above the line and below the line. As you can see here, 8 divisions. Since this is of 50 hertz, mean it is going up and down, so they will form a sinusoidal curve or a sine curve. Next, how many waves should we show in this itself? So remember to show the number of cycles. We take Fy divided by Fx, where Fy itself is the frequency of the AC supply. So in this case, it's 50 hertz. So how I know 50 hertz is going to state here. And Fx itself is the frequency of the time base itself. So we know that 0.04 seconds is, we can find the frequency 1 over 0.04, which is the period. This will give us as 25 hertz. So if this is 25 hertz, it tells us that there should be 2 cycles. So you should draw 2 cycles inside this diagram. Okay, so with that, we will end on this topic's stereo voltage. Thank you.